This is video number 3 for sections 7.6 and 7.7, finding the equation of a parabola in standard form. Let's remember what standard form looks like. Y equals ax squared plus bx plus c. We're going to talk about how do you find such an equation if you know some points on the parabola. Remember, if you know the vertex, you should not be doing what we're doing in this video. You should be using vertex form. We covered that back in the 7172 lesson. It was a pretty easy process because remember, if you knew the vertex, you could plug in the h and the k right off the bat, and then you did a temporary plug-in thing to figure out A. That's really a much easier process. We're just dealing with the case now where you don't know the vertex, in which case standard form is the way to go. Now here's the crazy part. If you don't know the vertex, you actually have to know 3 different points on the parabola if you want to find the equation. And the reason for that is that there are 3 constants here in standard form. Let's take a look at the example problem. So simple directions, find the equation of the parabola or the quadratic function that goes through these 3 points. We're not told that any of them is the vertex, so I just have to think of them as 3 random points on this parabola. How do you get started? Well, I don't really have any idea what to do other than the temporary plug-in, and I'm going to have to do it all 3 times. I'm going to have to do temporary plug-in with each point into that standard form. For example, when I take the first point, remember these are x, y points. A, B, and C, I don't know. If I knew A, B, and C, I'd fill them in and we'd be done. So you're filling in for x and y. The first one would be 1 equals A times 1 squared plus B times 1 plus C. Go ahead and fill in the other 2 points into the standard form. Here's what you should have gotten. Remember, you are filling in x's and y's each time. So in the second equation, the y got the 5, and the x slot got the 2. And then in the third equation, the y was the 15, and the x was a 3. You are not filling in a, b, and c because you don't know what a, b, and c are. Let's go ahead and clean up these equations a little bit. So my first equation, when I square that 1 squared is just 1, and 1 times a would just be a. B times 1 is b, and then I get c. Go ahead and clean up the other 2 equations as well. And here's what you should have gotten. 2 squared is 4, 3 squared is 9. Essentially, every time you do this, the same thing happens here. The coefficient in front of the a will just be the x coordinate squared because of the x squared in standard form. And the coefficient in front of the b will just be the x itself. This is 1, 2, 3. This is 1, 2, 3. And these are the squares of those numbers. 1 squared, 2 squared, and 3 squared. Okay, well, take a look at what we have now. Hopefully this looks very familiar to you. This is a system of 3 equations with 3 unknowns. It's a 3 by 3 system. Instead of x, y, z, it's a, b, c, but other than that, it's exactly the same. And so the next step is simply to use the algebra that we came up with earlier in this lesson to solve this system for a, b, and c. Once I have a, b, and c, I can write down the equation of my parabola. Let's go ahead and number the 3 equations. And then we have to decide which letter we're going to get rid of twice. Well, listen, in this kind of a problem, you should always, always, always stick with getting rid of letter C twice at the beginning. It's by far the easiest one because it doesn't have a coefficient, and it never will. It'll always just say plus c here at the end. So let's use, for example, equations 1 and 2 first. I can see that I'm going to have to multiply one of those equations by -1 to create a minus c. Let's do that. We would have -1 now, negative a minus b minus c. And now I can add those two equations together, and I get 4 equals 3a plus b. We've been calling that equation 4 in our examples. It's an equation that only has a and b. Well, now I need to come up with another equation that only has a and b. The easiest thing to do in these problems is just always use equation 1, making it negative like we did, and then adding it to each of the other two equations. So I used equations 1 and 2. Now let's use equations 1 and 3. So look what I've written down here. I wrote down equation 3, and then I already knew I was going to have to do that same -1 trick to equation 1, so I copied down that version of equation 1, the one that we used before. And immediately then, I can go ahead and add the equations together. And that's going to give me 14 equals 8a plus 2b. The c's dropped out once again. That's our equation 5 in this particular problem. Once I get to here, I now have a system of two equations with two variables, and my next step is to put those two equations together. And now I need to get rid of one of these letters. A looks pretty complicated. B looks pretty great though. I can fix equation 4 by multiplying through by -2, and that will turn it into -8, -6a, and -2b. And now if I add those bottom two equations together, I get 6 equals 2a. The b's drop out. This is our equation 6, the one we always are hoping to end up with, and I can see easily if I divide both sides of this by 2, I come up with a equals 3. Once you have one of your values, the rest of the problem usually goes pretty quickly. To get the next letter, it would be the b, which was the last one to drop out. I'm going to either have to go back to equation 4 or equation 5. Equation 4 looks pretty good to me. I'll recopy it, but I'll fill in the value of a that we just got and carry out the math. And I believe we're going to end up with b equals -5. Staying organized in these problems is half the battle. That's why I think numbering the equations can be helpful both for you and for me when I'm looking at your work. Drawing arrows and so forth can also be helpful. All I need to do now is find the c. I'm going to have to go back to either equations 1, 2, or 3. Equation 1 here, the original one before we multiplied by -1, that looks pretty simple to deal with. So I will copy that equation down, filling in 3 for the a and -5 for the b. I don't know c, and very quickly, of course, I can solve for c. When I add 2 to both sides, I'm going to end up with c equals 3. Now, remember the goal of this problem. The goal was not to solve a 3 by 3 system. We're just using that algebra to help us get to our goal. A lot of students will give me an ordered triple at this point. That's not what kind of problem this is. My job was to figure out the equation of that parabola. So now I have to go back to the standard form. I knew from the start that the final answer was going to look like this. I just need now to fill in my a, my b, and my c. And so for my final answer, I write down y equals, it's ax squared. Well, we figured out that a was 3, so 3x squared. And then plus bx, the b is -5, so that would be -5x. And the c is +3. Your x's and y's go back in now. We only temporarily replaced them earlier so we could figure out a, b, and c. This is the final answer to the problem. What we can do as an ending point is we can check this by using the graphing calculator. Let's go ahead and do that. These are really very easy problems to check on your graphing calculator. What I need to do is go to my y equals and type in the equation that we got. The 3x squared minus 5x plus 3. Make sure all your plots are are turned off there. And then for the window, I'm thinking the zoom 6, the Z standard option, should work pretty well. If it doesn't, I can always adjust the picture. Okay, well, I've gotten this parabola. Of course, I just need to make sure that it really goes through the 3 points that we thought it was going to go through. And I can verify that using the trace command. So if I hit trace, the first point, I'm looking back at the example, was the point 1, 1. Well, you can type the x value in trace mode, hit enter, and it will take you to that spot. And look, there it is, 1, 1. The next one was 2, 5. So I'll hit 2, hit enter, and I'm hoping to see, yep, there it is, a 5. The final one was 3. I'll hit enter, and sure enough, 315. I don't think I can see that point here because I didn't go up high enough to see 15, but nonetheless, it took me to that correct point. And now I know that we did our problem correctly. Remember, if you don't know the vertex of your quadratic function, you have to go through that process that we just went through with the 3 points in order to find the equation in standard form.